Hello, welcome to the AI podcast presented by Artificially. Today, our guest is Alexandru Baila, joining us all the way from Romania. Alexandru is a data scientist from a tech company called Endeavor. And today, we are going to talk about some cool applications of computer vision that he has worked on. So, with that small introduction out of the way, Alexandru, the stage is all yours.
Hello, and thank you for the invite as well. Today we're going to talk about a bit of computer vision, and we're going to focus in particular on an application which is based on basically just computer vision techniques that are being used nowadays. We're going to focus on this. I'm just going to pull up the presentation here.
Awesome.
So if you give me 1 second, I'll have it here. Yeah, there you go. So just gonna share my screen now. 1 second. So yeah, let's go. How do I share? Yeah.
It's at the bottom. Yeah.
Yeah. Okay. So can you see my screen?
Yeah, I can.
Okay. So yeah, as I mentioned, we're gonna talk about computer vision and how we use this to build certain application, and especially something for the blind people. First, about the agenda. This is what is going to be included in the presentation, and this is let's say the chapters of it. Now we're gonna go on to a little bit about me. I started doing data science about 3 years ago. I have some degrees in software engineering, which includes with a master's degree. I have an interest in research, and then I also am really passionate about building high impact solutions that generally help the society. I'm going to use throughout the presentation a couple of let's say acronyms. So when I say VIP, I don't mean very important person. I mean visually impaired person. DL is for deep learning, and CNN is for convolutional neural net. Let's start, I guess. So what's the main problem we're addressing? So I'm sure everyone's aware that nowadays, since a long time ago, there's this problem that people have where like they don't see, and that's called that people are essentially visually impaired or blind. And as of right now, there's about 36 million people who suffer from partial or total blindness. And out of these 14% are totally blind. To this, there's a couple of solutions that are already on the market, but there are only two. There's the white cane, which I'm sure everyone has seen, like people using it on the street, and they're quite common. But there's also guide dogs. But as you can see here, guide dogs are kind of expensive to train and also to take care of. So, and white cane is usually a cheaper solution, but still it doesn't achieve that that good results. So there's definitely room to improve here, I guess. So if we make a comparison for guide dogs, they provide security in the sense that you're essentially walking with someone, with someone who can maybe protect you in case of danger. They provide mobility. They generally guide the owner through and out of crowds. Travel can be faster, but it's a bit annoying sometimes that maybe the dog can go in certain ways that you're not expecting. Also, there's the human factor to the guide dog. So in the end, dogs are living creatures, and they bring a human vibe to the problem. On the other hand, guide dogs usually have dogs in general have a short lifespan, and guide dogs at the same time have a even shorter career, let's say, they generally work for about a maximum of 8 years, and then they become too old to rely on. Maintenance, as funny as it sounds, dogs must be continuously trained, and they must be handled very diligently. And also there's the guide dog health. So after all, guide dogs are still dogs, and they are very sensitive to diseases, and they can get sick sometimes, which can make it unreliable for a certain period of time. Now we're gonna go to the comparison to the white cane. Yeah, so walking cane or white cane, it's the same thing. What they bring to the table is basically their low-cost solutions. They're very cheap to buy. The cost is around $40 average. They are, well, there's little to no maintenance. They just have to be cleaned, and yeah, you have to make sure that you don't break them. And they provide tactile information. So you can push things with it, you can feel the surface, you can do all sorts of things. However, they become unreliable when the weather starts to get really bad. So if it's snowing outside, maybe the walking cane is not the best item to use. They're non-fluid. They can get stuck between cracks, and it can make you fall sometimes. Just imagine carrying like a stick and around you, and sometimes you can stick it in between things, and you might get yeah. So it can be annoying sometimes, and they don't provide that much awareness as dogs do. So if there's I don't know, an imminent danger coming towards you, the walking cane cannot bark, so you don't notice that. So that's a bit of a risk here. Yeah, so as I said, both solutions are a bit inconvenient. A guide dog can be expensive, and a walking cane is not efficient, and it doesn't provide sufficient support, let's say. And as a statistic, 5% of, let's say, VIPs use a guide dog for their daily routine. So they use a guide dog to basically do their daily activities, and the other 95% just use a walking cane or get help from a relative or a close person. So yeah. But what is for sure is that 100% of users are unsatisfied, and they could definitely benefit from a better tool, something which is a bit more reliable than this.
Yeah.
And yeah, so we can help here with machine learning, moreover computer vision. So yeah, what I mean by computer vision is computer vision by a whole. There's a set of techniques here and a set of principles that, if they're put in place, let's say in the right order and if they're configured well between them, they can provide a really viable thing. So for people that are not familiar with this, this is a very broad definition of what computer vision is, and it is concerned with the automatic extraction, analysis, and understanding of the information that's coming from a single frame or a sequence of images. And then it also involves the development of a theoretical and algorithmic basis to achieve automatic visual understanding. Now, it sounds very, let's say, complex, but essentially is teaching the machine what vision actually is. We don't know because we're used to it, but it's much more than that.
Yes.
So yeah, in that sense, it's a bit complex. Here we're gonna look at certain architectures, which are deep learning architectures. The first of which is object detection, and so object detection is basically the task of detecting instances of objects of a certain class in an image. And there's certain methods here that can be applied. Some state-of-the-art methods include one-stage methods, which can be, let's say, less accurate but faster. So for let's say if you just want to do a proof of concept or something like that, you
Right.
might prefer this one because you just achieve success faster. But there's also two-stage methods, right? Which are more accurate, but they require like more computational power. So if you are building a system and you have the resources, this is the way to go, I would say. Then there's also segmentation, which is the task of dividing the image into subgroups of certain elements that are from within the image. So basically, if you have a picture of, I don't know, a park, right? There you divide the items in the picture in certain classes, right? You have trees, you have benches, you have grass, you have maybe a bridge somewhere. So yeah, you annotate the things in the image based on classes. And here, what comes of interest to us is basically two things. Instance segmentation, which is basically one pixel belonging to an instance of a certain category. And then there's also semantic segmentation, which is one pixel belonging to just a certain category. So you don't differentiate between instances. That's the fundamental difference, I would say. And lastly, depth estimation, which is basically, yeah, it's very suggestive, I would say. You just measure the distance from each pixel and you estimate it relatively to the camera. And here we can measure depth in two different ways, depending on the type of camera we use. We have we can have a monocular camera, which is basically everyone's laptop surely has a monocular camera,
Yes.
and that means that it's a single point of view camera. Then you also have stereo cameras, which are multiple viewpoint cameras. So kind of like I think the new iPhones have stereo
Right.
cameras.
Yes.
Yeah, so those are what stereo stands for. Um, right. So firstly, object detection. Basically, you have an example here in the right what it actually means and what it looks like. Basically, it's basically a neural network that is composed of convolutional layers, pooling layers, dropout layers. These are for people who are not, let's say, up to date on these things. These are types of layers that, uh, mm, in short, they process the image in certain ways so that the network then can learn image data and, um, let's say, train with that, right? For convolutional layers, basically what they do is they produce feature maps out of the image, and then with the convolution operation, they feed input to the next layer with next layers, which are generally pooling layers.
Right.
Um, Pooling layers are basically decreasing the size of the feature maps because in the end, you also want an efficient network. So you want to decrease the image as much as possible, but still keep within good accuracies. You have dropout layers, which basically just drop a percentage of neurons from the neural net to avoid overfitting. And finally, we have fully connected and the output layers, which are basically, let's say, the last judge, as in they contain the weights and they have the decision, they make the decision that, for example, here, this cat is actually a cat, right? So what's the probability of this being a cat? And you generally, the answer when it goes out of the network looks like this, like a set of probabilities. In this case, it's a binary classification, right? There are binary possibilities,
Right.
dog or cat. So yeah, this is what the final layers usually do. Um, yeah, and as I mentioned, here is an example of what it looks like, the output. Next, yeah, we have object localization. It is basically the same thing. But here, instead of the output, instead of being a set of probabilities, is basically a set, well, some bounding box coordinates that are used to plot lines, well, to plot a box in the image so that the object is, well, located in the image. So as you see here, because the network has been trained on hundreds of thousands of pictures like this of cats and their coordinates within the picture, then it knows that this cat is present at this coordinates right here, right? That's the fundamental difference.
Right.
Okay. Now we also have here for object detection, we have some, let's say, better methods, I would say, which are RCNN, fast RCNN, and faster RCNNs. And basically what they stand for is region-based convolutional neural nets, which are basically two-stage detectors that combine both object localization and image recognition with the selective search algorithm. As you see in the picture here, I'm not going to go into too much detail about the selective search, but basically the algorithm searches areas that are very similar pixel-wise.
Right.
So, and generally this search is done within 2000 areas, let's say. And why do we have fast and faster? Because basically those are just improvements of the basic RCNN. For fast RCNN, we put some dimensionality reduction, and we compute basically these bounding boxes through regression. And for faster RCNNs, there's a new algorithm which is called regional proposal network, and that essentially means that we also run like a really simple CNN, like a two-layer CNN on the feature map which is generated. Feature map, as I mentioned before. That's the fundamental difference, I would say. Next, we have single-shot detectors. These are one-stage detectors which consist of just an ordinary CNN which is run on the input image, and that essentially generates feature maps, and then we have small convolutional kernels on the feature map in order to generate the object class and the bounding boxes. Now, there's a trade-off here because the SSDs in general achieve a good balance between speed and accuracy, but it is still too slow to run in real time. So what I mean by that is if you have, let's say, if you're trying to make glasses for blind people, you would need that information really, like you need to keep the information really up to date, right? So because the person moves really
And
fast.
probably you want to do that on the edge device as well, right? If possible.
Yeah,
Which
exactly.
means you have to do really fast computation.
Exactly. Yeah. So what I'm trying to say is that maybe, as you mentioned, if you do it on edge devices, this is not maybe a good idea.
Yeah.
And also it sits in the middle. So like this is slower than YOLO, which we're going to talk about in a second, but it's faster than RCNNs. It is more accurate than YOLO, but is less accurate than faster RCNNs. So it's really in the middle. It's let's say nobody's algorithm. So yeah. Finally, we'll look at YOLO. Maybe some people have heard of it. It is a really popular CNN architecture that is used to generate both labels and bounding boxes for objects by dividing the original image into multiple grids of the same size. And then for each grid, we detect, well, YOLO detects the object inside itself. What's the advantage of it is that essentially it makes a single forward step through the network, and yeah, it just manages to combine the elements of both image recognition and object localization. It's very fast. when I was working with YOLO, I was actually trying YOLO version 5, which
Nice.
was already really fast. Now we're on to version 8, I
Yes.
believe. And yeah, it's just so much of a difference, I can tell you.
And now you can do even more. You can do segmentation and everything.
Exactly. Yeah, I just saw it and I was like, whoa. I was trying to mix these a long time ago, but yeah, YOLO now provides this functionality also.
Yeah.
So yeah, YOLO is a really, really good choice if you work on edge devices. And for this case, therefore, it would be a clear winner, let's say. So as I said, it's very fast. If you don't have like a really, really good, and let's say a medium spec GPU, you can try YOLO on your own computer. It's fine. It will just run very, very well. Generally, I average
Nice.
around 5 FPS, and I have a medium spec computer, let's say.
Okay.
So yeah. Now, next we have image segmentation. And here we're going to talk about, as I said, semantic and instance segmentation. First of all, for semantic segmentation, there's a really popular module called UNet, which is basically it's a CNN architecture that performs semantic segmentation, but it's really, well, it's mostly used on biomedical data, for that case, biomedical images. The architecture is like an encoder-decoder type of system that performs, well, it just continuously downsamples the input image, and it also creates feature maps. And then from these feature maps, it then upsamples them into a new image and with the corresponding task. So basically it, as you see here, this is why it's called UNet, because it's a U form. You create the feature maps, but you also downsample the image, right? To
Yes.
identify what the pixels belong to. And this is very, very efficient because then you can mix them. So far, for biomedical image segmentation, UNet proves to be state of the art, or so it was at the time this presentation was made, but it's not too long ago, so it should still be the best in the benchmarks. And yeah, with the medium spec GPU, you can achieve really high uh, frames per second. So it's a really, really good architecture to try if you're working with biomedical data. Um, right. And then instance segmentation. As I mentioned, the difference is basically if you're doing instance segmentation, it's like differentiating between two sheep that look exactly the same. One's an instance of a class and the other is another one.
Right.
And that's the main difference here. For semantic, it's the same thing. Nobody cares. um, Here, let's say the key players are mask region CNNs, and yeah, I think mask RCNNs are basically the benchmark here. There are CNN-like architectures that they essentially work in the same manner. However, they generate 3 types of outputs: the object mask, the bounding box, and the class label. The architecture is quite similar as in a fast RCNN, along with the region proposal network. Um, yeah, as some observations here, the architecture is quite common. So it's not like a breakthrough like a transformer is nowadays.
Yeah.
But it's very, very, I mean, it's got a pretty good performance. With a medium spec GPU, again, FPS can be quite high. So for trying it out on your laptop or edge devices, it's a good choice. Right. Finally, depth estimation. Now, depth estimation is a bit overlooked on the market, I would say, because mm, so far, there's things like cameras from Intel, which basically, well, yeah, it's a paradox here. Cameras steal AI's job in this case because
Yes.
AI is not really developed that much here,
Mm.
but it's still, yeah, I guess there's quite a lot of potential here.
And we are talking about detection of depth from monocular camera, or because stereo camera is not that cheap and not that common, right?
Exactly. Yeah, we're talking about monocular here.
Yeah.
The Intel one I mentioned earlier is stereo, I think. Yeah,
Mm.
but that's quite expensive.
Right.
When I was working on this project, I think I was researching the market, and it was around 500 or 400
Oh,
not dollars, euros. Yeah,
that's
which,
costly.
yeah, it's costly. Exactly.
There is
If you
a device called OpenCV AI Kit. It has depth estimation as well with the cameras. So that is another device. It's a little bit cheaper, but
Mhm.
yeah, it's still costly. Not as cheap as the monocular cameras. Yeah.
Yeah, exactly. The problem is that monocular methods are not that efficient. I mean, well, they are efficient, but they're not so accurate. Yeah.
Mm.
So as a stereo camera would be, but I guess it's a, well, if you don't have the means to do it, it's a good compromise.
Yeah.
It's yeah, you're just working with the ideas basically. Um, what I wanted to say here is that what I worked with is called Midas, and Midas is basically a CNN that is based on regression, and it reproduces depth within images that come from monocular cameras. Midas was essentially trained on a lot of data, and by a lot of data, I mean about 10 different data sets that portray objects in different POVs, right? Because here we're talking about depth, and
Yeah.
depth is dependent on the POV. Some observations, as I said, it's a CNN. The architecture is very common. It is a lot more affordable. Well, it's free essentially than some other depth estimation engines, like I mentioned before, the Intel RealSense D series. And yeah, with a medium spec GPU um, and some, let's say, clever configuring, you can achieve high FPS. And what I mean by that is that you don't need to, depending on your type of project, you might not want to compute the depth every time, every
Mm.
frame, because you don't really care. Maybe you want to compute the depth when you actually have a frame that is of, let's say, of interest, right?
Right.
So yeah, you have to make use of the resources you have, or if you have the resources, yeah, good for you, go for it. Yeah, depends. So there you go. This was an introduction to computer vision and some techniques. Now, what I worked on basically, and it involves this kind of things, is a prototype that essentially can benefit the visually impaired people. Um, what I used here, as I said earlier, I used YOLO v5 and Midas and Python text-to-speech
Nice.
to build this. And what it essentially is, this is like a high-end schema, let's say. Um, Basically, I wanted this to be like an attachable device, like a let's say like a pair of glasses. And then with that pair of glasses, you would look throughout the room or the environment you're in. And if you're looking for, let's say, I don't know, your phone, I have it in front of me, my mouse, my notebook, but I'm visually impaired, I cannot see. I would use this this system to locate it.
Right.
Um, and what it does essentially, it searches for the, let's say, requested objects or list of objects for that matter. And when it finds them, then it saves that specific frame. Um, and well, the frame is pretty much identified with YOLO v5, right? Because um, you do continuous inferences with YOLO on your frames, and then essentially you find the right frame in which your object is present in. When you find that, essentially you extract the bounding box coordinates, And also, as I mentioned earlier, you have to be smart here because sometimes depth, well, it is affordable, but still it's a bit heavier than YOLO. You produce your depth map because you want to know where exactly or how far is it from you, right? But
Right.
it's because it's always going to be in front of you, but it can be like 30 centimeters, 60, even 1 meter for that matter. So uh, you need to know the depth. And then, yeah, you just produce the depth map, find out the depth, and yeah, you have your object location. Here's like a screenshot of how it actually works. So yeah, these are some metrics I was just using to monitor the behavior and the performance. But essentially, it found that my cell phone was exactly, and I say exactly, 13 centimeters away from the camera.
Nice.
Um, but yeah, this depth is still monocular. So with the means that I had, it manages to achieve pretty good results. Although I would recommend, let's say, stereo techniques here, based on my experience. Um, yeah, before I'll share this, I just want to say that um, in order to make the prototype more efficient for the visually impaired person, the following changes can be applied. So I have used object detection, but I would have preferred to use instance segmentation because there's been a couple of cases in which the object was located, and then let's say if how you see me here, right? The camera would locate me as a person, and then it would
Right.
draw the bounding box around me. But if I moved like that, the box would still be the same. But then the
Oh.
depth point, which is the middle point, is going to be pointed towards the drawer, which is behind me. And
Hmm.
then the depth would be different. So that's why I would suggest, if there are people who want to do this in the future, look out for instance segmentation. Using the mask and the exact footprint of the object is much better. Um, Yeah, and also the second idea is, yeah, as I said, you need to plot the depth point in the object mask instead of the bounding box. Um, if you want to deploy this system, don't use your laptop, use a more powerful device. Or if you have a powerful laptop, use your laptop. Uh, um, if you're working with speech to text, it's the PyTTS X3 is not that good. I have tried it and it fails well 50% of the time, and here it fails on like a native English. I had friends who tried it, but if you have a, let's say, a stronger accent, uh, yeah, it might not recognize you
Right.
uh, as I um, as I experienced in some occasions. And
Hmm.
also there's this technique called visual slam,
Yep.
uh, which is very like, I think it's very like under researched, I would say, still for this subject, but it can be a pretty good approach to the problem. This is just what we talked about here is very primitive compared to what Visual Slam brings to the table, but there's a lot of research to be done there still. So yeah, those would be my recommendations. Yeah, so before showing you a bit of an inference, yeah, as I said, with computer vision, yeah, there's all sorts of cool things we can do with it, but in the end, we can also use it to actually create some impact on society and actually help some people. Um, Unfortunately, there's little to no interest in this subject because, well, it's a noble thing, and sometimes businesses or uh, let's say important players on the market do not see a financial uh, profit, like a financial benefit here, so they say no. And but there's also at the same time there's huge potential. If we can build chatbots, chat GPT, and all sorts of things, we can build we can make our lives much easier. We can invest in people. We can actually help people who are underprivileged by using these techniques.
Really good
So
point. Really good point.
thank you. And yeah, we have to set our priorities a bit more straight, I would say. But yeah, it's subjective, I guess, here. So yeah, I think yeah, this is it for the presentation. Before I show you, if you have any questions, just go
Sure.
ahead,
I
shoot
have
out.
I have one question regarding masker CNN. Do you think it's feasible to run instant segmentation on an edge device? Isn't it computationally really expensive?
Uh, that's a good question. It depends on the edge device.
Mm,
If you're using Raspberries, if you want, you might want to try the most expensive one, which I
yeah.
think is also the best. Uh, is it the most powerful one? I'm not too sure.
I have one with 4 gigs RAM.
Okay,
Sorry, I think it's 8 gigs RAM.
okay,
And I ran mobile net on it. It ran pretty well.
okay,
It ran YOLO V5 pretty smoothly, but I haven't tried Masker CNN yet. But
okay.
MobileNet was sort of getting stuck a little bit. So I think I'm not sure if Masker CNN will run as smoothly as the other algorithms, but I definitely want to try. I mean, 8 gigs RAM is pretty high, but it's
Yeah,
no GPU though.
yeah. Still, but you don't need a GPU. I think if you have a really strong CPU and like a high
Yeah,
number of RAM, then it can achieve. You're always gonna have YOLO is always going to be the fastest.
that's true.
So you're
Yeah,
always going to get a decrease in in FPS for
yeah,
more expensive algorithms. I would say maybe give it a try, I guess.
yeah.
I haven't tried with Edge yet, but I would say if you achieve around 10, 15 frames per second with YOLO, you
Hmm.
should definitely try the other ones as well.
For sure. Yeah, I'm gonna try running V8 on the Raspberry Pi and see how that
Right.
goes. Because now we can do segmentation on V8,
Yeah,
YOLO V8.
yeah.
Interesting.
And I think, yeah, it should be also,
Yeah,
I'm not aware of how they built the segmentation pipeline, but I think it should be like the same kind of story, like really, really affordable on all laptops, I guess, right? That it's
I
still
think
YOLO.
so. Yeah,
That's their selling point after all.
yeah,
Okay, so if not, we can move on to the demo, I think.
yes.
Um, I'm actually gonna show you now. So basically, I don't know if you're gonna hear what this system actually speaks, but I'm not too sure if you're gonna hear the voice. If not,
Okay,
I'll let you know. But basically, what we're trying to do is we're gonna assume that I have lost my phone and I'm just visually impaired and I cannot locate it. But
perfect.
somehow I'm not gonna move my laptop around because the camera is attached to it. So I'm just gonna plot the phone like this, and it will tell me how far is it. So
Perfect.
let's. Do you see my screen? Or,
No, you have to change. I think you have to reshare again because
oh,
I
okay,
see. Okay, now I see the terminal.
that's perfect.
Yeah.
So we're just gonna run this. We'll let it wake up a bit. Did you hear that or?
I heard a really shallow voice.
Okay. It basically said that it's looking for cell phone and that this is your virtual assistant. Oh,
Gotcha.
yeah. Um, problem is I cannot do this with my camera on. So I have
Hmm.
to
Yeah, for
switch
sure.
off my camera 1 second.
Yeah.
Right, it's booting up now. So let me share my screen now. Okay, so can you see my screen?
Yes.
Okay.
Yeah.
So basically, this is like my front-faced camera. This is the room I'm in, and then if I put this phone up here, well, in a certain position at least. This is YOLO V5, so it's there you go. Yes. 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 There you go. So, you didn't see.
Yeah.
So basically, what it said is that cell phone found, and that it also it asked me whether I want to know how far is it, and it told me that it's about 20 centimeters away from the camera. And if I'm trying to look, it's about 20 to 25. So in that, let's say, area, I would say. I'm not sure. Were you able to hear or no?
Uh, for example, now I can see the depth map, not a depth map, the bounding box properly.
Oh, right.
Yeah, yeah, yeah. Right. Yeah, yeah. I see it now.
Yeah, there you go.
Perfect. Perfect. Yeah.
So, but what it said basically is that the information you see here when the bounding box is displayed is being spoken to me. So that's all. But
Gotcha. So it's
general,
like it says we found the phone, and
exactly,
because now we have a bounding box around it.
exactly, yeah. And
Yeah.
as you can see, it also my headphones are being confused to a cell phone because of
Right.
the shape. I don't know. It just sees them as a phone.
Yeah. Yeah.
For some reason. But yeah, that's due to the data it's been trained on. So
Or maybe
yeah,
you can play with the threshold a little bit, the confidence threshold.
unfortunately
Maybe
with
because of.
YOLO, I don't know if you can. You can do that
Mm,
with or I'm not aware of it.
yeah.
Although you can play with the threshold, yeah, but I've tried to do this with Detectron. Maybe you've heard of it.
Yep.
There you go.
Facebook
So
research. Yeah.
exactly. Yeah. So yeah, detection allows you to basically create a class in which you set the threshold to be as much as you want.
Mm,
And yeah, you can experiment with that.
interesting.
Yeah. So yeah,
Awesome.
this is a well in its true meaning a prototype. It's not I mean still deployable, but it's a starting point, and from here on yeah, there's
Yeah, there's a path
magic stuff.
forward. Yeah,
Exactly.
absolutely, absolutely. I love the idea of using some sort of visual device to help VIPs to help locate objects. One question I have is how did
Yeah.
you how did you input the like phone, for example? Yeah, do you have to like keep a picture of your phone on a directory, or how do you input phone, or is it looking for phone only?
Yeah. So basically, when you run YOLO, you can run it. YOLO has default classes, which are basically built in, and
Yeah,
for every inference, it searches for those classes. But you can also call it with certain parameters, and those parameters are basically the classes. And in this
gotcha.
case, well, for the sake of the demo, I put in phone. But when I was building it, I was trying to um, like uh, I was using Google Speech Recognizer. I was speaking into the microphone, and then it got what I was telling, like I don't know, fork, phone, or desk, and it was
Nice.
translating these things into like strings, and then those strings are passed as parameters to YOLO. So you can use
Brilliant.
YOLO with parameters to
Okay.
do this.
It sort of makes it clearer, the idea a little bit more for me, as in you use speech to text to say the name of the class that you want to detect, and then
Hmm.
it looks for the object. Yeah, that's brilliant.
Yeah,
Awesome.
thank you. So yeah,
Uh,
from my part, this was it.
okay, perfect. Before you have to leave, I want to ask you some general questions about the field of research that we are in,
Mhm.
if that's okay.
Sure.
Uh, so my first question is, what is the best way for a professional who is working on a different field, let's say, not AI or ML? What is the best way
Mhm.
for them to switch to this field?
Um, well, I don't think there's a the I don't think there's such a thing as the best way. Y- It's like doing a PhD. You have to love it. If you don't, if there's things you don't like, or you, for example, if we're talking computer science, I don't like DevOps. I just don't like that idea, and I would never try it because I just don't like it. And it's the same here. If there's things that you don't like about this area, don't try it because you will get lost there's a lot of maths behind, there's a lot of
Yes.
uh, concepts that you have to learn, yeah, principles, and you will just get lost. So I would say if you're passionate, start reading, start with perceptron, start with linear regression, start with these things, and yeah, just keep building block to block. You will get the hang of it sooner or later, and when you do it, it's really nice.
Yeah.
And yeah, I think this is the best thing to do.
Perfect. Uh, Another thing that I want to ask you is how difficult do you think to get into the research side of ML and AI? Not particularly engineering, but the research mostly. How difficult it is to get into that?
Um, to get into what exactly?
Uh,
Jobs
to,
or?
yeah, to get into the research jobs, machine learning research or
Mhm.
AI research jobs.
I would say not that difficult, given the fact that you know, I mean, if you have some knowledge about this, you have, well, not experience is a broad term, but if you have like little experience and you have, I don't know, ideas and you know what's state of the art currently, I don't know if it's very hard. I mean, I've done internships in research. I had little to no experience in this. Um, there's I wouldn't say it's that hard. It depends what opportunities you find. Mm,
I love that answer actually because I mean nowadays even if you have a degree from a university, I think still getting a good opportunity, finding out a good opportunity, even if it's an internship,
mhm,
but if it's something that you are passionate about, I think that's more important than having a degree from a university at this point.
yeah,
The way the world is moving. Awesome.
exactly.
And do you want to recommend some sources for the basic stuff, the background that we discussed today? For example, the background we talked about, object detection, segmentation. Do you want to refer to some sources that helped you research all this stuff, learn more about this stuff?
Yeah, sure. So at the time I was using Pluralsight. I think uh, I think you can get a free trial on it. Uh, so yeah, I was looking up on tutorials on Pluralsight. And then there's the obvious websites towards that data science, Medium, I think.
Yes.
And yeah, those are like easier to read. But if you really want to get into the depth of it, just look out for research papers. If you're if you actually care about things like what type of loss are we using and things like that, a research paper is the place you want to go. But if you're starting out, YouTube, Pluralsight, Udemy, I think, has tutorials. Um,
Nice.
yeah.
And finally, I ask this question to everyone, and it's a little bit of a controversial question. And it is that, do you think that AI is disrupting different fields of research or different fields of work, for both for good or bad, in terms of because some people say that AI is taking the jobs, but we as AI researchers, we always want to remind people that AI is also creating new jobs. So where do you lie in that spectrum?
I would have to agree with you. I think AI is not stealing jobs. For example, um, yeah, so for example, there's I forgot which state was in, but in America some time ago, or I'm not too sure. Yeah, I think in America or somewhere there was a robot that has been developed to actually say if a patient had cancer or not, and the accuracy was at around 99%, and that was AI. Now you can say here that yeah, AI is stealing the doctor's job, but it's not like that.
Yep.
Everybody who does a certain job or has a daily activity that it can become, let's say, monotone at times, that person will become an observer. And what I mean by observer is that AI is still just statistics. It's not actually intelligence. So you have to actually monitor what the AI is doing, because sometimes the AI might be wrong. We overhype it sometimes, but it actually can be wrong. So by observer, I mean you just have to basically annotate the situation as let's say false positive or something like that, and yeah, give feedback or things like that. So I don't think it will steal any job. It will create jobs, but they're gonna be called observers, or I don't know, prompt engineers, as it is
Right.
with case of Chat GPT now.
Yes.
It's not gonna steal jobs any soon. We will have to create a very uh, well built ecosystem, right, with AI, which is miles ahead of us, I think.
Perfect. Yeah, I love that answer. Awesome. Thank you so much for presenting such an awesome project and answering all the interesting questions. So with that, I'm gonna end this